cheese occupies a nutritionally complex position in the dietary conversation. It is calorie-dense, high in saturated fat, and frequently positioned as something to consume sparingly. But within the cheese category, there are distinctions worth making. And the comparison between aged Gouda and fresh mozzarella on vitamin K2 content reveals one of the most pronounced nutritional gaps between two products that superficially seem to belong to the same food category. Fresh mozzarella, particularly the water-packed variety made from whole milk, is a pleasant, mild cheese with good protein content, adequate calcium, and some fat-soluble vitamins. Its vitamin K2 content is negligible, however. Fresh cheeses are produced through brief fermentation or simple acidification, aged for minimal time, and contain bacterial populations that have not had the opportunity to perform the metabolic processes that generate menaquinones. The K2 that makes certain cheeses nutritionally distinctive is simply not present in meaningful quantities in fresh, young cheeses. Aged Gouda tells a fundamentally different story. During the aging process, which for quality Gouda can run from 6 months to 2 years or more, bacterial cultures active within the cheese convert vitamin K1 present in the milk fat into vitamin K2, specifically in the -6 Malawian Quachas through -9 Malawian Quachas menaquinone forms. These longer-chain K2 forms accumulate in the cheese fat as aging proceeds, with more extensively aged cheeses generally containing higher K2 concentrations. Research has measured aged Gouda at 50 micrograms of K2 per ounce or more, a substantial dietary contribution from a food not traditionally associated with vitamin K in nutritional databases, most of which measure only K1. The clinical significance of this K2 content connects to outcomes that K1 supplementation and high K1 foods do not reliably produce. The Rotterdam study, a large Dutch epidemiological investigation, found that higher dietary K2 intake, but not K1 intake, was associated with reduced coronary heart disease risk, reduced aortic calcification, and improved all-cause mortality. The Dutch population in that study obtained most of their K2 from aged cheeses and fermented dairy, Gouda-type cheeses specifically. This is not an isolated finding, and it provides a biologically plausible explanation through K2's role in activating matrix GLA protein, the enzyme responsible for preventing calcium deposition in arterial walls. The caloric density warning is real and relevant. Aged Gouda runs approximately 110 to 120 calories per ounce, with most of those calories from saturated fat. For individuals managing caloric intake carefully, incorporating aged Gouda as a K2 source requires accounting for its energy contribution. The practical strategy is portion precision, 1 to 2 ounces of aged Gouda alongside a meal, rather than grazing quantities, which delivers meaningful K2 within a manageable caloric frame. The cheese board as a health strategy is not absurd. It requires only that the board feature aged rather than fresh cheeses, and that portion size receives the same attention it would for any calorie-dense food.